Here we're going to talk about the graphs of sine and cosine with changes in period, amplitude, and reflection. So the first graph up here is the graph of y equals sine. And remember, sine just starts at 0, and at pi over 2 it goes up to 1, and it comes back down to 0. It drops to -1 at 3 pi over 2, and back to 0 at 2 pi. So the graph of sine, this is one period, just rises and then falls, and then back to 0. And the graph of cosine starts at 1, right? So when x is 0, cosine actually starts at 1, drops down, and at pi it's at -1, and then 2 pi it drops or comes back up to 1. So what we're going to be doing is whenever we graph, we're going to be talking about finding the new coordinates of 5 key points, or 5 significant points. And for sine, those points are, here's the first one, 0, 0. Here's the second point, pi over 2, 1. Here's the third point, pi 0. Fourth point is 3 pi over 2, -1. And fifth point is 2 pi 0. So we're going to ask ourselves, how do each of those 5 points change to get the transformed graph of sine? And likewise for cosine, key point 1, key point 2, 3, 4, and 5. So with that in mind, let's go ahead and look at some changes in period, amplitude, and reflection for the graphs of sine and cosine. Let's graph y equals 3 times sine of x over 2. We're asked to sketch one full period. Okay, so first of all, I'm noticing that the 3 here, right there, gives me a change in amplitude, as we've discussed. So the new amplitude, that is the amplitude for this curve, is the absolute value of whatever number is there. So the absolute value of 3, which just happens to be 3. So there's our change in amplitude. Now there's no reflection because there's not a negative here. We'll see an example of that in a moment. Only when there's a negative here do you get a reflection across the x-axis. So let's write that down, that there's no reflection across the x-axis. But there is a change in period, and whenever you have x multiplied by a number, so sine of 1/2 times x, you have a change in period. So let's write down the new period. And this is how you always find the new period for a sine or cosine curve that's been transformed as far as period is concerned. So the new period is going to be, well, the old period, which is 2 pi, and that's always the case because this is the period of original sine, divided by whatever number you're multiplying x by. So here I'm multiplying x by 1/2. So it's 2 pi divided by 1/2, and that gives you your new period. So 2 pi divided by 1/2 is equal to, well, we can write it out, but 2 pi divided by 1/2, and then what you do is you say that's 2 pi times the reciprocal, right? So times 2, so the new period is 4 pi. So we have a change in amplitude and a change in period. Now what we're going to be doing is we're going to be getting in the habit of, as I mentioned, transforming those 5 significant points. So what we do is we take the argument, that is whatever you're taking sine of, in this case x over 2, and you set it to equal to where sine used to start and where sine used to end. And let me go back to the previous page for a moment to clarify what I'm talking about here. So you can see how sine used to start at 0 right here, right? And it used to end at 2 pi. So we're going to set x over 2 equal to 0 and x over 2 equal to the 2 pi. Let's go back. That is, we're going to set this x over 2. So x over 2, we're first going to set it equal to 0, and then we're going to set it equal to 2 pi. And this is how it always goes. Okay, and you have to solve each of these equations. So I'm going to multiply both sides by 2. So I get x is equal to 0, and likewise over here, the 2's cancel likewise, and I get x is equal to 4 pi. Now what we found is the new starting point and the new ending point for this graph. So no longer does the curve start at 0 and 2 pi like it did on the previous page. This curve starts at 0 and ends at 4 pi. Okay, so beginning and ending. Then what we do is we take the ending point and subtract the beginning to get what's called the step size. Well, we take that and then divide by 4. So what we're going to refer to as the step size is going to be the end, so 4 pi. Take away the beginning, which is 0, and then we're going to divide by 4 because we're going to have 4 intervals to consider. And that's going to be, well, 4 pi divided by 4, which is just pi. Okay? So once you've done that, now you're ready to scale the x-axis. What you do is you start at the new beginning, in this case 0. So we're starting at 0, and you step in this far. Okay? And you do that until you get to the end. So you step in once, and that's pi. You step in again, that's 2 pi, right? I'm stepping in pi every time. Step in one more time, 3 pi, and then one more time, and that's 4 pi. That's how you scale the x-axis. Now you stop when you reach the endpoint. So what's going to happen is that 1, 2, 3, 4, 5, these are going to be our key points once we have the y-coordinates. We basically have the x-coordinates of the key points. To find the y-coordinates, what you have to do is consider the fact that you're multiplying by, in this case, just positive 3. So the amplitude is going to be 3. So we go 1, 2, 3, 1, 2, 3, and we scale the y-axis like that. -1, -2, -3. Now sometimes, remember, we're going to have graphs in the future where you have all of this and then like you add 4 or something. If that was the case, I wouldn't scale to 3, I would scale to 7 because I'd be adding 4 to the values that I get here, which would be a maximum of 3, then plus 4 would give me the 7. But in this problem, this scaling will work on the y-axis. Okay, so now what we do is we ask ourselves about the previous y-coordinates. So let's go back to the first page again. So this was the graph of sine, right? We say, what happens to the y-coordinate? Well, the y-coordinate used to be 0, okay? And then the next one, the y-coordinate used to be 1. Let's keep that in mind. Back to the problem we're working on. So the y-coordinate used to be 0. What do we do with that 0? Well, we multiply it by 3, right? Because it's 0 times 3, and that's still 0. So we still have 0, 0 as a key point. At the first step over, we used to get 1, as we saw in the previous graph. Now you're taking the 1 that came out of this, and you're multiplying it by whatever number is there, in this case 3. So instead of getting 1, we get 3. So boom, and that's, of course, reflecting the fact that we have a new amplitude, right? An amplitude of 3. Here you used to get 0. 0 times 3, that's still 0. Okay? At the fourth key point, we used to get -1. Now we get -3. And I got that by multiplying that -1 by the 3. And then finally, 0 times 3 again is back to 0. So this is our new curve, right? It's the amplitude's changed, but so is the period. The period is 4 pi. Let's sketch that in now. Okay, and that's one full period. And if you're asked to sketch 2 full periods, then what you do is you basically repeat this pattern once again, right? You'd scale this out to 8 pi, and you'd continue that curve. Let's try another one like that, but now involving cosine. Okay, so we're asked to graph y equals -2 times cosine of pi over 3 multiplied by x. Sketch one full period once again. So just like before, we think about first the amplitude. So the amplitude is the absolute value of whatever number you're multiplying the function by. So it's the absolute value of -2, which is +2. So there's a change in amplitude. Now there is a reflection, okay, across the x-axis, and I can see that because we have a negative sign here. So we have an amplitude, change in amplitude, change in reflection, or we have a reflection. And we also have a period change, right? The new period is the old period, which is 2 pi divided by, in this case, whatever you're multiplying x by. Well, it's always whatever you're multiplying x by, which in this case is pi over 3. So you divide by pi over 3. And you can write that out if you want, if that helps. So it's 2 pi over 1 divided by pi over 3. But then you multiply by the reciprocal. So 2 pi over 1 times 3 over pi. And the pi's cancel, and you get just 6. And that's your new period. Okay, let's write that down. Our new period is 6. So just like before, what you do is you set the argument equal to where cosine used to start, which is 0. So we set pi over 3 x equal to 0, and then we set the same argument equal to where cosine used to end, which is 2 pi. And that's why it's so important to know what the original function looked like, right? Because we reference it quite often. So to solve these equations, I'm going to multiply by the reciprocal of pi over 3, which is 3 over pi. And here, these cancel, right? That's the whole point. And you get x is equal to 0. And likewise, 3 over pi. and the pi's cancel and you get 6. So x is equal to 6. Now in this case, just like the previous example, we ended up getting, ending at exactly the same value as the period. That's not always the case. Later on we're going to have horizontal transformations, and we'll find that where we end is not necessarily equal to the value of the period. But for these examples it is. Now we're going to find the step size. So I'm abbreviating step size with 2 s's. And what you do is you take the right, which is 6, subtract off the left, which is 0, divide by 4. So we get 6 over 4, and that's equal to 3/2. So what we're going to do, just like before, is we start at the left, 0, and we step in this far. And we do that until we get to the right endpoint. So we start at 0 on the x-axis, and you step in 3/2, right? So let's call that 3/2. Step in 3/2 again. That brings you to 6/2. Again, 9/2, and finally 12/2. Now I know that 6 over 2 is 3, and 12 over 2, we know that that's 6, but I like to leave it as 6 over 2 and 12 over 2 because it helps for me remember that it was simply related to the previous values through whatever the step size was. So it's fine to leave it, even though it can be simplified. Okay, finally the y-coordinates. You want to say where, what did it used to start at and where did it used to end? Well, remember, cosine used to start at 1, right? Cosine used to look like this. So instead of 1, well, you have to multiply that 1 by whatever number is there, which is -2. So instead of starting at 1, it's going to start at -2. So we're going to scale the y-axis accordingly. So let's go 1, 2, 1, 2. So 1, 2, and then -1, -2, okay? So cosine used to start at 1, multiply the 1 that you used to get by -2. Here's the first key point. Second key point was 0, multiply that by -2, and the y-coordinate is still 0. And then remember, cosine used to go like that, right? So right here we used to get -1. Now you're multiplying the -1 by -2, which is +2. Okay, at the fourth key point, you used to get 0. You still get 0 because 0 times -2 is 0. And then finally, cosine used to end at +1. 1 times -2 is -2. So now it ends at -2. And these are the new 5 key points. 1, 2, 3, 4, 5. And the cosine curve is going to look like this, right? There's been a reflection. Let's go ahead and sketch that in now. And there's our graph. So notice there are a few changes, right, compared to regular cosine. First of all, the amplitude is no longer 1. The amplitude is clearly 2. There's been a reflection across the x-axis. The graph sort of looks upside down in reference to the x-axis. And finally, a full cycle you have to go through 6 instead of 2 pi. And so all those transformations occur because of the the alterations to the basic form of cosine that you can see, right? The negative gives us a reflection. The absolute value of a number here changes the amplitude if this is not 1 anymore, the absolute value. And then whatever you're multiplying x by, if there's anything but a 1, you have a change in period. Okay? So that's how you sketch graphs of sine and cosine involving amplitude, period, and reflection changes. Until next time.